In this video, we'll move into Chapter 8 and cover all the ideas that are covered here. Now, in the grand scheme of things, Chapter 8 is a very important chapter in what we're going to do with the rest of statistics in this class. But as far as our specific purposes, you'll notice that these notes will be fairly short and that there's no homework that goes with this. So really, what this video and what these notes are really for are just to give us a little picture of where we're going, to get that necessary information so that we're ready to move into chapters 9 and 10 and finish up this semester. So, chapter 8, we're talking about this idea of sampling variability and sampling distributions. And this idea of sampling, we've been talking about that a lot, but just this idea of sampling, we want to take a little bit of a fresh look at that. Because we've already established the idea of having a population, having all of the items, the people, whatever it is that we're trying to look at, record, or measure. And that, practically we can't always do that, so that we often like to look at samples. We look at smaller subsets, and we only sometimes look at specific groups. Maybe instead of looking at all college students, we only focus on the freshmen. Or instead of looking at all workers in this country, we focus on workers over the age of 50. So a lot of possibilities, but the idea of a sample is still having a piece of a larger population. So we've already mentioned all of that, and we've seen a lot of those discussions. We've had a lot of those discussions, I should say. We've seen a lot of the results of what's good, what's bad. And in general, one of the ideas of statistics is trying to take that sample data to tell us about the entire population. And that's where we really go here. Because now we want to start looking at samples as individual data values, so that we're not just looking at a sample to tell us about the population as a whole, but how we could actually compare samples to each other. So again, instead of just looking at a group of 30 items in my sample, to take those 30 items, to take that sample, and to almost reformat that as one data value, to compare all of the samples in the same way that we try and compare all of the data values. So that's pretty deep. That's a complicated idea. So again, 8.1, we get through a lot of the basics of sampling, but then really 8.2 is where a lot of this picks up. At the bottom of page 435, we start getting this little chart, and they talk about the general properties. They remind us some notation we should already know. We have X bar is the sample mean. We refer to N as the sample size. Mu would then be the population mean, and sigma would then be the population standard deviation. But now, if you look at the top of page 436, and then on the top of page 437, well, here's the top of page 436, and we're looking at this chart, and then in a moment we'll talk about this little idea at the top of page 437, and then we'll formally talk about the central limit theorem here. That is without a doubt the big highlight from this section. So what are we talking about here? Well, again, with all of that information already understood, that if we have a bunch of sample values, we could get their mean, and that's the sample mean. Well, how many of these values did we have? That's N. And as we always say, we try and use this to then generalize the idea of the population mean. But now they push things a little more. They start using this notation, the mean of all of the sampling distributions, the standard deviation for all of the sampling distributions. And they start to point out that if we want to start looking at samples as new sets, well, the mean of the sampling set is the exact same thing as the mean of the entire set. Okay, that's the first key point, is that these are exactly the same thing. But then secondly, if I start looking at a standard deviation for a sampling distribution, it's not the same as the population standard deviation. We'll do this little adjustment, that we will treat this value by looking at the population standard deviation and dividing by the square root of n. That we're trying to use the number of data values to not modify, but to try and correct that if we have more data values, that the standard deviation becomes more significant, so to speak. So those are the first two properties that I listed. But now when we go past this, this is the real big thing. So this is nice, and we'll come back and point these out when we need to in chapters 9 and 10. But here's the real key. Properties 3 and 4. What do we know about the sampling distribution? Well, if the initial data that we're collecting in the first place is normally distributed, well, then that sampling distribution is also normally distributed. So as we kind of saw at the end of chapter 7, normally distributed information goes with the bell curve, and when we know that, the computation is not bad. It doesn't mean they're easy problems, but as far as computation, the normal bell curve is very friendly. But now property 4, this is again where the central limit theorem comes in. If I do this sample and I want to compare this sampling distribution to the entire distribution, well, even if my initial distribution is not normal, so long as n is sufficiently large, then the sampling distribution can be approximated by the normal curve. It's not normally distributed, but it's close enough that the values we find can be treated like they're normally distributed. So that's the big thing. If you flip to page 437, what does it mean for n to be sufficiently large? That just basically means our sample size needs to be greater than or equal to 30. There's a few other tiny little conditions we'll get into, and we're not trying to make this tricky, just trying to point out this is the necessary information that lets us work in chapters 9 and 10. When we get there, that'll let us do what we do there. So the last two things I want to point out, and that's the end of chapter 8. So again, we pointed out the idea of the central limit theorem, and I'll just try and sum that up very quickly here. That the central limit theorem says that if n is sufficiently large, so that'll be greater than or equal to 30, my sample size, again, if my sample size is greater than or equal to 30, then we can approximate the sampling distribution using the normal curve. Again, we could treat it like it's normally distributed. And that box above it, well, if we're going to use the normal curve, we're going to need z-scores. We're going to need that z-score table again. But here's going to be the one difference. Instead of our traditional z-score, data value minus mean divided by standard deviation, well, now we'll do the equivalent of that. We would do data value, which now in this case would be a sample mean, not just one value, but the mean of an entire sample. We'll subtract that from the sampling population mean, which that's where we pointed out that that would be the same as the regular population mean. And we'll divide by the sampling standard deviation, and that's what I pointed out over here. That sampling standard deviation will be the population standard deviation divided by the square root of that. So all this sounds very complicated and very technical. So again, this is not an easy chapter to read, but there's no homework here, just a few ideas. I suggest scanning this over a little bit, but then really as we get into chapters 9 and 10, you'll see, and I'll remind you where these ideas keep coming up. The very last thing, section 8.3, instead of just looking at data values and means, they just quickly talk about proportions, and that we can do the same thing for proportions that we do for means. That we'd have lowercase p would be the population proportion, the proportion of all people or items in a population that does something, and then we'll use little p hat for the sample proportion. And that we could do very similar things there. That we could use the sample proportions to tell us about the population proportions, treat these like distributions, and we have very, very similar type of work.